In this lesson, we'll talk about the initial feasible solution of the LP transportation model using the least cost method with the degenerate case. So far, we have already discussed about the northwest corner rule in getting the initial feasible solution. Now, the least cost method is the second method that we'll discuss. So, our objective is to find the IFS using this method for balance, unbalance, and degenerate cases. Here are the steps in getting the initial feasible solution using the least cost method or the greedy method. First, select the cell with the least cost. If there is a tie, select 1. Allocate the shipment so as to exhaust the supply or meet the demand or both. If the supply was exhausted, cross out the entire row of the cell. If the demand was met, cross out the entire column of the cell. Adjust the amount of the supply or the demand affected by the allocation. And then after that, we repeat the step 1, this one, in choosing the least cost until all supply has been exhausted and demand has been met. State the initial feasible solution and compute the associated cost. Alright, this is what we had for the example 1 in the previous lecture video. We have already solved this using the northwest corner. Take note that the answer here will be different from what we had in the northwest corner. Sometimes they will be the same, but that is only coincidental. Okay? Take note, class, that it is totally fine to have different answers as long as you follow the procedures. The bottom line here is that this is only the initial feasible solution. What matters is the optimal solution, which will be discussed in lecture 5. Alright, let's solve this using the least cost method. The procedure tells us that we choose the least cost among all the costs. We have here 2, which is the lowest of all. And then we are going to exhaust as much as possible here, as many as possible. So we can allocate 23 here, so that we can already cross these out, because 23 here has already been exhausted. Next, the next least cost is 4. Okay, take note that 23 has been met already for destination A. So there is a remaining 8 for this one. Next, we can already erase this. Alright, what is the next least cost? So we only have 4 remaining. Take note na itong 6 hindi na yan kasama kasi na-cross out na natin yan, as well as the 7. So we will proceed with 8. Okay, how many can we allocate in A, in this one, in this cell? We already have allocated 8 here. How many can we allocate here? 37. It follows that we will allocate 12 here automatically. And then here we have 30. Para lang tayo nagsusudoku rito. If there is already blank that can be filled out, blank cells that can be filled out right away, let's fill those out. Okay, let us check for degeneracy. Take note that this one was not degenerate in the northwest corner, but let's see here. So how many sources and then how many destinations minus 1? Is this equal to the occupied cells? The number of occupied cells is 5. Okay, so 5 is indeed equal to 5. So this is not degenerate. Next, let us state the IFS, the initial feasible solution. How many will be transported from source 1 to destination B? So let's write those. Okay, for let's use y because that is the variable used in the LP model. Y1B 30, Y1C 12. Next, Y2A is 23. And then Y3A is 8. And Y3C is 37. Don't forget to get the total pala. So the total of this one, total supply and total demand, 110. So take note, this is a balanced problem. Okay, now let us get the associated cost. Therefore, the cost is equal to the following. Like the northwest corner, how did we do that? We just simply multiply the allocation to the corresponding cost. Okay, 30 in any order. 30 times 9 plus 12 times 10 plus 23 times 2 plus 8 times 4 plus 37 times 8. How much? Okay, 764 pesos. Again, how do we interpret this? It takes 764 pesos to transport these goods from sources 1, 2, 3 to destinations ABC. Ito lang, itong mga to. In the northwest corner, we got 1,004 for this problem. So, generally, obviously, the least cost method provided us a lower alternative. Okay. Example 2. Alright, least cost method, we are going to choose the lowest. We have 3 lowest costs here. 0, 0, 0. Now, which are we going to choose? According to the rule, there's no particular criteria whether when there's a tie, you will just choose any of them. However, in this case, let us choose the one that will exhaust or will deduct most supply. Okay, so I'm going to choose this one, 20 here. So, this will already be crossed out. Okay, I chose this one because this has the largest supply among the 3. However, class, if you will choose this, go ahead. For example, ito yung gusto mo. Mag-iiba nga lang yung sagot mo ng konti, but that is totally fine. Or, if you choose this, mag-iiba rin yung sagot mo. Totally fine as well. So, I will make that as your exercise. Okay. Ayan, choose this as the first allocation. Separately. Okay, I will let you do that. Ito yung number 1, tas ito yung number 2. Okay, however, for this item, I'm going to allocate 20 here. Okay, so we cross these out. This is the first least cost. Next, the next least cost is 4. Okay, I'm going to allocate how many? 32. Saan galing yung 32? Syempre, dito. Okay, ayan. So, mawawala na to. Let us cancel this para hindi makagulo sa pag-select natin ng next least cost. Next that we'll have is 8. Okay, here we can allocate 50. Okay, the supply is exhausted at the same time the demand was met. Okay, so we cross this out because there's nothing more to allocate here. And then after that, we have 16. how many can we allocate to 16? So be careful, you have to consider how many is left for this one because we have already deducted 32. We have already met 32. Okay, 32. 60 minus 32 is 28. That is still acceptable and doable because pasok pa naman yan dito sa 84, correct? Pasok pa yan dito kapag pinag-add mo. Alright. For the last one, we can already fill that out with 36. Okay, this is already crossed out as well as this one. Okay, so we already have our answer. Now, let us check for the degeneracy. How many sources? 3. How many destinations? 4, including the dummy. And then minus 1, is this equal to the, what do you call this? Occupied cells? Our occupied cells are 5. We have 7 minus 1, 6. This is not equal to 5. So, therefore, this is the degenerate. Let's continue. Let us have the artificial allocation. Now, since we are using the least cost method, we are going to allocate the artificial 0 to the least cost. Okay, so we have two options, either here or here. Okay, let us choose this one. I will allocate the artificial 0 here. So, this is now non-degenerate because I have already allocated the artificial 0 here. So, let us write the IFS. Okay, the quantity to be transported from source 1 to B is 32, to A 36, to B 28. Okay, for the dummy, let us denote that as capital D. Y2D 20, Y3C 50, and Y3D 0. Okay, you have to write also this one, the 0, because it will be considered later when it comes to the optimal solution. So now, let us get the corresponding cost. 36 times 19 plus 32 times 4 plus 28 times 16 plus 50 times 8 plus 0 plus 0. Okay? Saan galing yung 0 plus 0? Ito yun. Alright, for this, we get 1,660 pesos. The northwest corner rule gave us 2,840 pesos. Example 3. Solve for the initial feasible solution. Again, here is our tableau. Choose the least cost. Okay, the least costs are of course the 0, 0, 0. Okay, again, let us choose the ones that with the highest demand. Okay, I'll choose this one. Again, you can choose this exercise. Okay? So now, let us cross this out. Okay, and now, what is the next least cost? 11. Okay, let us meet the demand 10 here. Okay, so the demand for destination C has been met already. After that, we have 12 and 12. This and this. And then we have remaining 70. Okay, how will we allocate this one? We can already deplete this, meet the demand here. So 23 will be gone, and then the remaining quantity here will be 10. Okay. Can you follow? 30 plus 10, 40. Okay. And then after that, here, we can fill this out automatically. 30. Okay, it's already done. Oh, let's check for degeneracy. We have 3 sources plus 3 destination minus 1. Is this equal to 5? Okay, the number of occupied cells is 5. So, this is not degenerate. I will write the initial feasible solution here. Take note that, again, the initial feasible solution tells us how many will be transported from the source to the destination. So, let me just write them. Here's the initial feasible solution. Let us now get the associated initial cost. Therefore, the initial cost is 30. Okay. Let me just write all of these. For this one, we have 1,280 pesos. From the northwest corner, we got 1,290 pesos. So, a little bit close to what we got here in the least cost method. However, you can try to get this one if you choose to allocate 30 here instead of this one, instead of what I did. So, you might arrive with a lower initial cost. Let's have example 4. Take note that this example 4 was degenerate for the northwest corner. However, here, let us check if this is degenerate. Least cost method again. The least cost is 1 peso. Okay, let us allocate 15 here to meet this demand against the 60 capacity. Okay, so let's cross this out. And then after that, what is the next lowest? 2 and 2. Okay, let's check first how will we allocate this. For 60, there are 2 possibilities, no? You can allocate 20 here so that you can already erase this. Okay, and allocate another 20 here. Or, you can, here I will allocate 40 here and nothing here. So, this one will be automatically 20. And this one will be 35. And this one will be 5. Okay, again, for your exercise, I want you to try different allocations for the instances that there is a tie. Okay, let's check what is the total for this 35 plus 20 plus 60. That is 115, correct? 35. And then, for the demand, this is indeed a balance problem. Okay. So, let us now have the, tama ba yung mga nilagay natin? 35, 20, 60, 60. Okay. Let us now check for the degeneracy. How many? We have 3 plus 3 minus 1. Is this equal to how many do we have? 5. Okay, 5 is equal to 5. So, this is not degenerate. Unlike in the northwest corner, this becomes degenerate. Alright. I will now write the initial feasible solution. Next is to get the cost. the associated initial cost. Be careful with the multiplication. 40 times 2, 15 times 1, 35 times 3, plus 20 times 5, plus 5 times 5. Okay. For this, we have 325 pesos. From the northwest corner, we got 600 pesos. So this is lower than what we got from the northwest corner. Next, let's have the worded problem. So if you remember from the northwest corner, we have already solved this one. Now, let us use the least cost method. Okay, let us denote these as 1, 2, 3. We have already stated it on the problem. And then A, B, C, D. Least cost. So the least cost that we have are 5, 5, and 5. So let us allocate as much as possible. As many as possible. So 2,000 here. So we already crossed this out. Also this one. Next. 4,000. So the demand has already been met. So we already crossed this out. So gawin natin kulay pink to para pareho yung kulay. Next, for this one, for the destination A, 1,500. So, wala na to. Okay. What's next? So, there is an unoccupied column B, destination B. So, we can already fill those out. 1,425 and how many? 1,075. Okay, let's check if these are correct. Okay, so all of these are correct already. So let us check for the degeneracy. How many sources and destinations, including... Okay, how many sources and destination? And then minus 1. Is this equal to 7 minus 1, 6. So how many occupied cells? We have 6. So this is not degenerate. We can now proceed to write the initial feasible solution. So, let me write those. Okay, halimbawa dito, let us use X, not instead of Y. So, of course, don't forget to let X be X sub ij be the number of fruit boxes to be transported. Okay. So, let us write those. X sub 1A, 1,500. X sub 1B, Makati to Manila, 1,000 pesos. X sub 2B, Muntinlupa to Manila, 425. Muntinlupa to Muntinlupa, 4,000. Okay, and then Valenzuela to Manila, 3B, 1,075. And X sub 3D, Valenzuela to Valenzuela, 2,000. You will see that the largest quantities are when from the same city to the city. For example, Makati to Makati, 1,500. Muntinlupa to Muntinlupa, 4,000. Why? Because the cost is relatively small. Valenzuela to Valenzuela, 2,000 boxes because the cost is small. Alright, so let's now solve for the associated cost. 1,500 times 5 plus 1,000 times 10 plus 425 times 16 plus 1,075 times 13 plus 4,000 times 5 plus 2,000 times 5. How much? Alright, we have 68,275. Our answer in the northwest corner was 98,375, which is definitely larger than what we had here. For your exercise, this is also the same with the one that you had in the northwest corner. So you will solve this using the least cost method.